All right, good evening everyone. Welcome to session 4 of our initial C++ module. So Tom, I think already asked this, but I wasn't paying attention. Is there anyone here who's here for the first time tonight? 2 of you now. Oh, well, welcome. Welcome to our, tonight actually a very little group. We do usually have a few more people than this, but you know, tonight you're quite lucky, you get nearly one-on-one tuition. So yeah, you've joined us in on the 4th session of our module. So it might be that tonight, I don't know about your sort of level of experience with other programming languages, but it might be that tonight you're sort of a bit like, what's going on? Because, you know, you've missed the first 3 weeks, unfortunately. The good news is it's pretty easy to catch up because all the videos that we have, all the sessions that we've done, we have videos for. We are live streaming this now. And all those recordings are available on our YouTube channel. So that's youtube.com/cpplondonuni. And you'll find a playlist on there that I think is called Initial C++ Spring 2020. And that has the first 3 sessions from this module. So you can catch up. Also, the slides are available online. And there should be a link in the description to the video as well for how to get the slides. Yes, so... also for the benefit of the newbies, because I put this slide up every week and everyone gets really bored of it, but you haven't seen it yet, so I get to do the same spiel I do every single week. Which is to say that we really like to hear from people, we really like to know what we're doing well, especially even more so, we like to know what we're not doing so well, what we could do better. That's how we improve. So one way you can talk to us is via email. The other way, another really good way to contact us, to contact other students, other learners around the world, in fact, is via a chat application that we make use of called Slack. So if you're, I mean, it's very widely used in the programming world, this app, Slack. So you can use it via your web browser or you can download, you know, for your computer or for your phone, the Slack client. There's a Slack workspace. I think that's why. No, I think that's why we've got so few people tonight. Everyone's worried about the germs. That's what I'm going to tell myself. Anyway, so there's a Slack workspace called CPP Lang. It's got a couple of thousand members from around the world. All sorts of rooms in there discussing different aspects of the C++ language. We have our own little chat room. We sort of piggyback off it. That's #CPPLondonUni. So you can join that. It's got I think we've got a couple of hundred members in there now. So if you've got questions, want to discuss anything, talk about the weather, talk about how you're really worried about the coronavirus, then you can pop in there and we tend to be on there a lot of the time. Another really great resource that's on the same Slack workspace, there's another room that's called #Learn, and this is intended for C++ learners, not just from this group, but around the world. Anybody who's learning C++, has questions, wants to know answers at 2 o'clock in the morning. Well, this is a worldwide group. There's always somebody awake, and yeah, #Learn has lots of experts in there who are really happy to answer any questions that you might have. So I think #Learn is a really great resource as well. That's there. So to join this Slack group, just go to that URL that's on the screen, slack.cpp.al. You'll see it's got a little box on there for you to pop your email address in. It'll send you an invitation with the link. You choose a password, you know, the usual kind of thing. So yeah, head on to that URL and you'll find all the instructions. All right, so last time, 2 weeks ago, who was here 2 weeks ago? Was anybody here 2 weeks ago? 3 of you. Ah. You were here. Excellent. Well, last time we had what people refer to as an install fest. So we got everybody set up with a C++ compiler, which is something that takes your source code and processes it and generates a program that you can actually run on your computer. So we got everybody set up with a compiler, and we got everybody set up with an IDE. integrated development environment, basically a fancy text editor for writing code in. That was a sea lion thing that Tom was talking about. Both of these things are free. Well, one of them is you need a license for it, but we can offer it to you for free as long as you're a student here. So we got everybody set up with that. So if you missed that last week and you want us to help you get started, then when we have a bit of a break, just let us know and we can do that. So after we've done that, we had another look at if statements. So this is something we talked about the previous week, but 2 weeks between sessions now is quite a long time. So sometimes, I'm not going to do it today actually, but sometimes I'll spend a bit of time just going over the essential points of what we talked about a couple of weeks previously, just to refresh it in everybody's minds. And then we went on to talk about this type called standard vector, at least a sort of high-level overview of this thing called standard vector. And standard vector is what other programming languages might refer to as an array or a list or sometimes an array list. It's basically a collection of some elements of another type. So you can have a vector of integers, that is a collection, an ordered collection of integers. You can have a vector of strings, which is a bunch of strings. You can have a vector of floating point numbers, right? So just as, I don't know if you're familiar with Java or Python or pretty well, no, every single programming language has some version of this. In C++, for odd reasons, it's called a vector. And because it's not built into the compiler, it's part of the standard library, it has this std : prefix. Don't have to worry too much about what that means right now, just remember that you have to type it. So again, if you missed this a couple of weeks ago, then don't worry, you can go back and watch the video. You can fast forward through the boring bits and find out what I was talking about, and the slides are also available. So this week, we're going to be going around in circles. And we're going to be talking about loops. We're going to talk about loops, doing things over and over again, doing things repeatedly. And again, just as with if statements and vectors, this is something that every programming language does. Many of them actually do it in exactly the same way as C++ does. So again, if you've done any Java or C# or even JavaScript, you'll probably be quite familiar with this. But we'll go over the syntax, we'll go over how you use these things in C++. And then, if we have time, which we probably will, because we've got quite a small group tonight, we're going to go on to talk about pass by reference, what that means and how it's different from pass by value, which is what C++ does by default. So that's tonight's menu. So let's get on with it. Well, actually, first of all, I've made the same mistake I always do. I said last week. What I meant was last time, so 2 weeks ago for you guys. I left, after we'd been talking about standard vector, I set a little exercise, which I left you with as a bit of homework. And basically it was just a bit of practice of using this standard vector thing. So I wanted you to create a vector of strings called names, and initialize it with the names of people on your table. This room is now laid out for examinations, but previously we had long tables, so create, I just want to encourage people to get to know each other. Initialize the vector with the names of people on your table, and then vector has this command push back, so you can add new items onto the end of the vector. So I wanted you to use pushback to add 3 more names to the vector. Then I wanted you to print out the number of elements, the number of things in the vector. And then, which is relevant, leads on to what we're going to be talking about tonight, I wanted you to print out every element of the vector. Sorry?
Display this function.
To print out on the screen, yeah. So here is the way I did it. So first of all, we have to tell the compiler which standard library components we want to use. In this case, we want to use the it's called the IO stream component. That's input and output streams. That's so we can print things out. And we want to use the vector components. And hopefully, oh no, I forgot because I'm an idiot. You probably need to do hash include string in angle brackets as well to tell it we want to use the standard string component. I forgot that because I'm silly. So we declare our main function. This is the function that gets automatically run when we kick off our program. And here we go. We are declaring a variable of type vector of strings. So vector is a special type, something called a generic type. It can hold any kind of, almost any kind of type that we like, but all of the things in the vector have to be the same type, right? So as I said, we can have a vector of integers, we can have a vector of bools, we can have a vector of floats. In this case, we say we want a vector of standard strings. So that's what these angle brackets mean. In this case, anyway, we want a vector of strings. So we're declaring a variable called names that is of type vector of strings, and then we're initializing it with 3 made-up names: Arthur, Beatrice, and Clive. So at this point, after this line is run, we've created a vector and we've initialized that vector so that it has 3 elements in it. 3 strings: Arthur, Beatrice, and Clive. Then we go on and we use this pushback command. So this adds a new element onto the end of the vector. So we say names dot pushback. So again, if you're familiar with Java, C#, Python, whatever, you'll recognize this. This is a method call. And if you don't know what that is, don't worry about it too much. It's basically giving a command to this object that we've created. So we're saying to it, okay, add a new string Tom to the end of the items that are already there. And then the second one, add a new string Ollie to the end. And then add a new string Michael to the end. So after we've executed these 4 lines, well, how many elements is our names vector going to have in it after we've executed these lines? Sorry? 6. Yeah, absolutely. What are they going to be? Sorry? All the ones in red, yeah. Arthur, Beatrice, Clive, Tom, Ollie, Michael. Yes. So we can ask the vector how many elements do you have, and that's with this size command. So this size command tells you how many things the vector holds. So we print out, I have, in this case, 6 names. And then finally, the last thing I asked you to do was to print out every name in the list, in the vector. And the way we do that, or the way we can do that, there are multiple ways to do it, as you're about to see. But the easiest way to do it is to use this, what we call a range for loop, to say, okay, for every string name in our names vector, print that name. And that's going to repeat it for every name in the vector. So if this last bit seems a bit strange and mysterious, well, that's what we're going to be talking about today. So any questions on this before we move on to some new stuff? No. By the way, don't be shy by putting your hand up and interrupting me at any time. Otherwise, we're going to be done by like 8 o'clock. So please do interrupt me. if at any point anything is not clear.
Okay, so CDD is cout is it for?
So this is the way that we print things out in C++. So other languages have, a function that's like print or printf. C++, being a bit weird, we use this this idea of a stream. So if you imagine there's like literally a stream of water, and you chuck something in it, and it travels down the stream, and it ends up somewhere over there, right? Well, that's sort of the analogy. So something over there in this case is like your screen, your terminal window on your computer. And so first of all, we chuck the string I have, and that floats down there and pops up on the screen. Then we run names.size, yeah, and it pops out, and then the names, and that's how it works. These things? Yeah.
Why is there 3 of them?
So this is something that's just that's kind of a bit strange. This is in this case, what it means is pass this to the stream. So this is a stream. We're passing that thing to it, passing that thing to it, we're passing that thing to it in that order. So it's the idea of you're sending it into the stream. If you see what I mean.
Just a quirk of the language?
Just a quirk of the language, yeah, pretty much. Yeah.
Can you explain me for it?
The whole of the rest of today is going to be about that for loop. So, or rather, building up to talking about that for loop. So, I will happily talk about it about now, actually. So, here we go.
Could you for a second just back because I almost done.
So when we watch back the video, we can see all of this on the screen?
Yes.
And see you?
You can't see me, no, but you can hear me and you can see the slides. No, I'm too shy to appear on camera. Also, we don't have a camera. So, yeah. All right. Does anybody recognise this? Or are you all too young? You remember it?
Basic?
Well, any sort of basic, really. They're all pretty similar. So I'm old enough that the first computer I had was a Commodore 64, and that when you turned it on, you had BASIC. And the first computer program I ever wrote was this. Except it didn't say loops in C++, it said my sister smells, because I was 10 years old, and that was really funny.
I remember doing this in Dixon's. We had a computer set up.
Yeah.
Yeah, so we just type stupid messages and then go to 10 means that
Yeah, and it just runs it forever, because what it does is it prints something, and then the next line says go to line 10, so it prints, so it goes to line 10, over and over again. It's a loop. This is not how you do loops in C++, but, you know. The point is, loops are an essential building block of computer programs. So we talked about one building block a week or two, or a session or two ago. That's if statements. So if statements are a way of making a decision. Right? If you want to write a program that does, well, pretty much anything like non-trivial, you need a way of making decisions. You also need a way of doing something repeatedly, over and over again. And we call those things loops.
I've got a problem with this program. Can't start it. It has 3 problems.
Okay, I'll come and look at it when we have a break. So C++ has 2 keywords for adding loops to our program that we're going to talk about. First is the keyword while, the second one is the keyword for. And again, these come from the C language, from which C++ derives, and there are a whole bunch of other related languages that have used the same syntax as C. So again, all these what we call the curly brace languages tend to all do this in a similar way. So if you're familiar with any of those, then what we're going to talk about tonight will probably be quite familiar. And in fact, we have just on the last slide seen one use of the for keyword with vectors. So printing out each element, doing something repeatedly, looping around. So let's begin at the beginning. Let's begin with the simplest type of loops, and that's the while loop. And a while loop simply looks like this. While some condition is true, perform some action. Okay? So this is the simplest kind of loop we have available. While this condition is true, repeat. So if we imagine with a program, we're running down, we reach this while command, this while statement. So what happens? Well, the first thing it does is it looks at this condition and it says, is this true or false? So just the same as it did when we were talking about if statements. When we had an if, we had a condition, it decides whether the condition is true or false. Well, it does the same thing with the while statement. It gets the while statement. First of all, it tests the condition. If the condition is true, it enters what we call the body of the loop. That's the bit between the curly braces. Enters the body of the loop, runs all this code, and when it reaches the end, instead of an if statement would just continue down here, but instead a while statement jumps back up to the beginning. And when we're here, well, we test the condition again. And if it's still true, we run the code again, and we jump back up, and we test the condition. And if it's still true, we again and again and again. If at any point, any time we jump back up here, we test the condition, if at any point this evaluates to false, then we skip the body of the loop and we continue running our program from everything that's after this closing curly brace. Does that make sense? Yeah.
Can you have a while within a while?
Absolutely you can, yeah. So now, here's a question for you. What is the minimum number of times that our while loop, the body of our while loop, may be executed? So if you imagine we had some instructions in here, some print statements, some maths, whatever it may be, it doesn't really matter. What's the minimum number of times this do something code may execute? 0, absolutely, yeah, no, that's absolutely the right answer. So if we get down to the while statements, the first time we test the condition, if this evaluates to false, well, we're just going to jump straight over it and never execute that code. So the minimum number of times that this loop may run is 0. Okay, so that was a bit abstract. Let me show you an example that will hopefully make things a little more concrete. So, I initialize an integer I to 0, and I say, while I is less than 5, do some stuff. And the stuff we do is we first of all print I, followed by a space, and then we increment I. So this ++I is just shorthand for incrementing the value of the integer, doing I equals I plus 1. So what's going to happen is, first of all, we initialize I. We get to reach the while statement. We evaluate this. We say, is I less than 5? Well, the first time we go through, I has value 0. Is 0 less than 5? Is it? Is 0 less than 5? Not a trick question. Yes, yes it is. Yes it is. So this condition is going to be true. So we're going to enter the body of the loop. And it's going to print out 0. Sorry. And then it's going to increment I. So I is now has the value 1. We reach the closing brace of a while loop. We jump back up to the top. And now I has the value 1. So we say, is 1 less than 5? Well, yes it is. So again, we print out 1. We increment I again. Has the value 2. 2 less than 5, yes, etc., etc. Until eventually we get I is equal to 4. Is 4 less than 5? Yes it is. So we print 4. We increment I, so I is now equal to 5. At this point, we jump back up to the top of the while loop. And we say, is 5 less than 5? 5 is not less than 5. So 5 less than 5 evaluates as false. And at this point, we jump over the body of the loop and we continue with the rest of our program. Well, in this case, there is no rest of our program. We just finish there. So what this program is going to do is it's going to print out 0, 1, 2, 3, 4. With spaces in between. So is it clear what's going on here? Yeah, good, good. So now you know how to do loops. And in fact, believe it or not, you do know how to do loops in C++, because everything else, or almost everything else I'm going to show you, boils down to writing a while loop. There are some ways to make it a bit easier and a bit shorter, but if you understand what's going on here, then you understand loops in C++. This, if you understand this, that's the key. Everything else you see, you can more or less bring back to something that looks like this. Almost. There's a sort of slight wrinkle in what we call a DoWhile loop. So DoWhile loops are almost exactly the same as while loops. There's just one little twist. So first of all, what does it look like? Well, a DoWhile loop is so called because it consists of two keywords. It consists of the keyword do and then while. Do something while condition. And this works just like a while loop with the difference that instead of testing the condition first, as we do with the while loop, with the do while loop we run the code once and then after that we test the condition. And if the condition evaluates to true, we jump back to the top of the body, to the beginning curly brace. So a while loop evaluates the condition first, a do while loop evaluates the condition after. That's the only difference between them. Now in practice, you don't often see do while loops used in the real world. While loops get used quite a lot. Do while loops aren't used all that often, but you do come across them, you do see them, so I thought I can't just leave out something that's kind of fundamental in the language, so I thought I'd tell you about them anyway.
Ask a question.
Yeah.
Earlier on I asked you about while, having a while within a while.
Yeah.
And the only reason why I asked that question is because I remember at the time that I was mucking around with where it was showing me all sorts of things, but it's really, really simple. why there would be a DoWhile and some of the sort of if things that go on.
Yeah.
I can just about remember some of them, but the DoWhile, I sort of remember. And I remember thinking that, let's say for instance you have, let's say that someone's got a security key.
Yep.
They plugged it in the wall, and then your code says, do this while it's plugged in.
Yeah.
Is that how it's used? Will it do? How to describe it? Alright, so is it better to have it the other way round? It might be a better way to describe it. While my security key is plugged into the wall, then code is allowed to be used.
That is almost always the way that you will see it done.
Okay.
Yeah.
So
Yeah. I would say like 95% or more of the time.
yeah, that's the safest
Yeah.
way to do it. Is that
Usually, I mean, I'm about to show you an example of what a do-while loop does, and I actually had to really think to come up with an example, right? Because there aren't a lot of the situations where this sort of naturally comes up. But, so I had to kind of create one artificially. So yeah, I would say the normal style while loop where the while is on the top, that's probably like, I don't know, like 10, 20 times more common than this is. But again, I thought for completeness, I ought to show you this version as well. Both a while loop, sorry, yeah.
At the end of the condition, is that a colon? Oh.
Sorry, that should be a semicolon. The software seems to have cut off the bottom. So yeah, it should be a semicolon, like you get at the end of every C++ statement. So yeah, sorry about that. I don't quite know what's going on with the with the formatting. It seems to have put a space in the middle as well. So the only difference between a while loop and a do-while loop, they both perform some action whilst a condition is true. The difference is the point at which we do the testing. So a while loop, we test first. If it's true, we run the code. Then when we get to the end, we jump back to the top. With a do-while loop, first we run the code, then we test. And if the test is true, we jump back up to the top. That's the only difference between the two. So I'm going to repeat the question I asked a couple of minutes ago. What's the minimum number of times this code, what's written here is something, what's the minimum number of times this will run? Once. Yeah, absolutely. We get to the do, we perform this action, then we test whether to continue. So if the condition is false, well, we just carry on. And that is the key, pretty much the only difference between while and do-while, is that a do loop executes the body at least once, and a while loop potentially doesn't execute the body at all. Right, that is the only reason you would ever use a do-while loop, is because you want to run this code once, at least once. Right. And if you think about it hard enough, we could translate this into a normal style while loop by writing the code up there once and then doing a normal style while loop that has the same body after it. But do-while is just kind of like a shorthand way of doing that. So let me show you what this looks like. Well, first of all, a bit of a brain teaser. This is a normal style while loop, not a do-while loop. So the while is at the top. So my question is, what is this code going to do? Everyone at the back of the room is being too still. The lights are turned off. So what is this code going to do? Well, first of all, we're creating a variable called I of type int, and we're initializing that int to 1. Sorry? You think it won't run? Yeah.
Because you don't know how the closing works.
Where?
For the main function.
Well, I haven't got there yet. There's a bunch of code that's about to appear. I can't persuade Keynote to do things out of order. Yeah, but you're absolutely right. This code basically does nothing. So we're going to initialize I to 1, and the first thing we're going to do is we're going to test. Is I less than 1? Is 1 less than 1? No. So in that case, we never execute the body of this loop. We just skip right down to here. And in fact, if you've got a smart enough compiler, it will probably warn you that this is what they call dead code, code that can never actually run. Okay. So you can probably guess what's coming up, but let's do it anyway. Let's initialize another int, this time called j, again equal to 1. And this time, got exactly the same body with j substituted for I, but it's a do-while loop instead. So what's going to happen this time?
Once will be done.
Sorry?
Once will be done automatically.
Yeah. This code is going to execute, is going to print out j equals 1, followed by a space. It's going to increment j, so j is now equal to 2. Well, 2, we didn't even need this line, but 2 is very definitely not less than 1. So it's going to run this code, it's going to test, is 2 less than 1? Well, it's definitely not. So there's the closing brace to keep Alex happy. So it's going to run this loop once, and then it's going to fall out of the loop, which happens to be the end of our main function as well. So this entire program is just a very, very long-winded way of printing the line j equals 1, followed by a space. Okay. Does that make sense?
Yes.
Yes, yes. Any advance on yes? Yeah.
Will that code just keep running, even though it only shows j equals 1?
No. So what's going to happen is, well, first of all, okay, as I said, we're going to skip right over this first one. We're going to run this code once, then we're going to test. Is j less than 1? Well, after we've initialized j to 1, it's going to run this code, so it's going to increment j. So, well, the first time we get to here, j is going to be equal to 2. And it's going to say, is 2 less than 1? Well, that's not true. So we continue with, if we had any other code below this while loop, it would execute that code, but we don't. We just have the end of our main function. So that's our program is going to finish. So this is, what, like 10 lines of code or something. All it's going to do, most of it is useless, because all we're going to do is print j equals 1. There are much easier ways of doing that. So the point of this slide was I wanted you to understand the difference between a while loop and a do-while loop. And there's only one difference, which is that do will execute the body of the loop at least once, or once before it tests the condition, whereas a while loop will test the condition first. So you can sort of maybe kind of think about it as like a while loop that's upside down. I don't know if that helps.
If you want something to run at least one time, that's where you would use it.
Yes. And as I said, do-while loops tend to be quite rare in the wild. Wild? No, that was a bad choice of words. Anyway, while loops are vastly more common, right? So you quite often see things that look a bit like this. This is a lot more rare, but all you've got to bear in mind is it means the same thing, but we run this first. All right. Any more while we're on the subject? Any more questions about while? Awesome. for now, we move on to for loops. All right, again, this is something that all of the, pretty much, so the for keyword comes from the C language. Lots and lots of languages inherited the C syntax, the C keywords for the basic things like loops and if statements and stuff. So there are a whole bunch of languages that have for loops with exactly the same syntax as C and C++ have. So if you've done JavaScript, if you've done Java, if you've done C#, whatever, you will probably be familiar with this, and they work in the same way in C++. So a little while ago, 2 slides ago, I put up an example that looked like this. I created an int. I said while that int is less than something, in this case 5, do some stuff and then increment the counter. Right? This is a way of running some code a set number of times, in this case 5 times. So before that, in the previous example, we used it to print the numbers 0, 1, 2, 3, 4. Right? This is a really typical pattern, or a pattern, a way to do things a set number of times. And this is really, really common. This idea of wanting to do something a set number of times is really, really, really common. Really, like, by far the most common type of loop that you will come across. It is so common, in fact, that C++ and C before it has a special word just for doing this, just to make writing this shorter. And that's this for keyword. So we call it a for statement, and a for statement has 3 parts to it. It has the initializer, the condition, and the increment. Oh no, don't do this to me. Well, for some reason, if I put the closing brace on, it corrupts the display. So just imagine there's a closing curly brace there. So a for statement is a way of doing all these steps in one line. Okay? That's all a for loop is shorthand for a while statement. Syntactic sugar is what people call it, because it makes your program sweeter. So this is shorthand for this. So 3 parts separated by these semicolons. Right, so the first part we call the initializer. So here I've said int I equals 0. That's the int I equals 0 in the while loop. Then we have the condition. In this case, I is less than 5. That's the bit that goes in the brackets after the while keyword. And then we have the increment, which in this case is ++ I, which again is the thing that you would put at the bottom of your while loop. So every single for loop you ever see can be rewritten as a while loop that looks like this. That's why I said if you understood that slide where I did the while loop, where we looped over something, where we looped over and printed 0, 1, 2, 3, 4, if you understood that, you understand how a for loop works. All you need to do is mentally translate it, go from this one-liner, you can expand it out into these separate lines here. So first of all, we initialize, in this case an int with the value 0. Then we test, is this, or in this case, is I less than 5? Yes, it is. So we execute this, do stuff, then we increment the counter, then we run the test again. So then we're going to say, is 1 less than 5? Yes, it is. We do stuff again, increment the counter, test again, and so on, until we're asking the question, is 5 less than 5? And at that point, our condition is false. So we're just going to continue. Again, you have to imagine there's a closing brace there. And then we continue with any other code that followed the for loop. So the really key thing to understand from this is every single for loop can be written as a while loop. All this is shorthand for doing these lines at the top. Is that clear? So most of the time you will see for loops used with integers, just as we had on that screen. So int I or some integral type. Int I equals 0 whilst I is less than 10, I plus plus or plus plus I. But actually that's not required. So you can put pretty much any old C++ code you like in the 3 different parts of a for loop. So 3 different parts with the initializer, the condition, and the increment. Most often it will be create an int, test whether that int is like less than some value, and increment that int. That is like 90% of for loops look like that. Probably more than 90% of for loops. But in theory, or in principle, we can use any old C++ code we like at these 3 different parts. So, and when we do that, oh, come on. We can use any old C++ code we like for these 3 different parts. This pattern is overwhelmingly the most common, but it doesn't have to be. And particularly C programmers, they like to get quite clever with the way they write for loops. But if you ever, and it will get to, once you've seen this a few times, int I equals, this becomes like just, you don't even really kind of analyze what the 3 parts are. You just recognize this as do something 5 times, right? You start to get like whatever the mental equivalent of muscle memory is. You just look at this and know, okay, that's doing something 5 times. But it's possible that you can put weird things in here, and sometimes people do, people who like to show off and make life difficult. Whenever you come across that, and this is something I still do, you can mentally translate it back, or it doesn't even have to be mentally, you can do it on paper. Translate it back to a while loop, and then to me at least, that becomes more clear what it's actually doing. One particular thing is that C++ allows you, or C as well in fact, lets you omit any of the initializer, condition, or increment. You can leave them empty. You still have to put the semicolon in there, but you can leave any of those parts empty. And if you leave the condition part of a for loop empty, that's equivalent to true. It's a condition that is always true. Effectively like loop forever. Right? So this, assuming we put something in the dots, this is a legal line of C++ code. In fact, we don't even have to put the spaces in there if we really want to be terse about it. So what is this going to do? Sorry? So we've had 1 vote for nothing. Well, let's translate this back to a while loop. So we've got 4, I'm just going to write it as like A, B, C, like that. And then ... whatever the code is. So we've got our 3 parts, our initializer, our condition, and our increment. We can rewrite this as a while loop, that is line A, while B, like stuff, sorry, shouldn't be there, like stuff, whatever this is, followed by the line C. all your compiler does when it sees a for loop is it translates it to this code. This is just shorthand for a while loop. So we're allowed to leave any of them blank. So do I have an eraser yet? So what happens if we leave this blank? Well, we just get rid of this. Okay, fair enough. What happens if we get rid of C? Well, again, we just erase the increment. So now, for nothing condition nothing is exactly equivalent to a while loop. It's a slightly odd way of writing it, but it's exactly equivalent to a while loop. The only special thing you have to remember is that if we leave the middle one blank in a for loop, so ABC, if we leave the condition blank, when that gets rewritten as a while loop, it's as if we've inserted the keyword true into the while loop.
Do you need like the way? Does it need to be a 0 or 1? 0 for true.
True is, so C++ has a Boolean, a bool data type, and true is a keyword that is, and a bool is either true or false, and true is, well, represents true, and false represents false. So a bool is, can only ever have two values, right?
Default is true.
Sorry?
So the default is true, but will it always say true if you leave it open? Like that.
So if you leave the middle, the condition part of your for statement blank, that is equivalent, when it gets translated to a while loop, it's the equivalent of putting the word true in the condition of while. So it's a condition that's always true.
You could also stick true in the middle of the for loop, and it would go.
Yeah, so you could do this.
Same thing.
Yeah. Yeah.
Is this specific to the for loop that blank is true, or is it a general thing? So
No, it's absolutely specific to a for loop. Specific to a for loop, because if you were to omit this, like that, that's a syntax error, right? This is not a valid program. Right? You need to have something, when you write a while loop, you need to have something in the condition part, otherwise that's an error. But for a for loop, again, I think it's just like shorthand, just because this is, as I have said, this is a shorter way of writing a while loop, so they said, well, we'll let you write it even shorter just by implying that if you leave the second part blank, we're going to interpret that as meaning true. So that's like a special case. Again, it's not something you see very often. I would say that's questionable code. If it came up in code review, I'd be like, come on, don't be lazy. Right? Keystrokes don't cost you anything. Just write it out properly. Yeah.
The problem of mine is when we use numerical conditions, we can see from two will be affected. But if we use true, what will be the...
Okay, well, let's see. Well, what is this going to do? While true, do stuff. Forget about for a moment. What does this do?
Unlimited cycle.
Infinitely.
This is an infinite loop. This runs the code forever. Yeah. Well, hang on. This runs code forever. So what's going to happen here? Well, we're going to reach the while loop. It's going to say, is this condition true? Well, it is literally true, right? So we're going to run the code. We're going to reach the closing brace. So it's a while loop. We jump back up to here. Test the condition again. Is this true? Yes. Run the code, jump back up to the top, and every time we test this condition, it's going to evaluate to true. And you might say that's kind of crazy. My program's never going to terminate. This is awful. Why would you want to do such a thing? Well, it turns out, as we're going to see in a little bit, there are ways to jump out of a loop. And this thing of loop forever is actually pretty useful. If you're running a graphical program, like a something with a user interface, typically what you want to do is have like a while loop that constantly looks for user input, right? Just continually test, has the user pressed on any buttons or typed anything on the keyboard, that kind of thing. Yes?
In Pascal, we used repeat until key pressed, so if we typed a certain key value, it was monitoring the key value. If we press the key, stop the loop, otherwise not.
Yeah, so like I say, every single programming language there is has some way of doing loops, right? It's essential. You can't write any meaningful program without having some way of making decisions and some way of doing something repeatedly, doing some way of looping. So let's come back to the question. What does this, assuming we had some valid code where these dots are, what does this line for colon, 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 colon?
Unlimited loop too.
Yeah, this is an infinite loop.
Going straight to the while.
Yeah, because we can translate this exactly into a loop that is while true. And this thing, for some reason, I don't know what it is, but for some reason, writing an infinite loop like this is beloved of C programmers. Right? I don't know why. They love writing loops like this. In fact, they'll usually leave out the spaces as well. Right? C++ programmers much more often will write this version on the board. C programmers, I don't know why it is, but they seem to much prefer that because it's fewer keystrokes, I think. I don't know. There's a tax on characters or something. Yeah.
Can I ask a point? It feels like a silly question.
No, there are no silly questions.
Can that code, that forever loop,
Yeah.
can that cause crashes or viruses?
Um,
Or can you introduce a value in the first, not the condition, but in the integer part, and you then introduce a value in there?
okay, so you've got a couple of different questions in there. So let's deal with the second one. There are a couple of ways that we can control the way we iterate through. So another word for doing this looping is iteration, right? There are a couple of ways we can control this. In particular, there is a word that we can use just to immediately exit out of a loop at any time we like. So while in principle this is an infinite loop, there are ways of leaving it, right? As the first one, can this be used? Can this cause problems? Potentially. I mean, if you have problems, sort of security problems that allow a malicious attacker to overwrite parts of your code, then they could insert an infinite loop that constantly eats more disk space to clog up your server and cause a denial of service attack. In theory, these things are possible.
Quick point. So you can't really write code to cause viruses because viruses are intentionally written by people who want to cause some kind of damage. They don't happen accidentally.
Yes.
Could it result in an exploit? So could your code have a vulnerability that somebody could utilize? Potentially, because there's any bad way of writing code, it's generally unlikely that an infinite loop would introduce a vulnerability directly introduce a vulnerability letting someone exploit your code. I mean, pretty much any game that you play out there will have an infinite loop in it because while you're playing the game, it's just
While true, read controller inputs, display polygons on the screen, right? That's the way a game works. Until eventually, on modern consoles anyway, the console's operating system will eventually terminate the program when if you press the PlayStation button in the middle. That talks to the operating system directly, but yeah. This is the most important line on the screen. That's the reason I put it on the bottom where you can't read it very well. Sorry. A for loop is always, always, always just shorthand for a while loop. Any time you have a for loop, you can expand it out, write it longhand as a while loop. Right? Yes, you get used to the pattern of seeing it yourself, particularly the int I equals 0, I less than something, I plus plus. That, as I say, you develop like the equivalent, mental equivalent of muscle memory and just recognize that as do something n times, right? It's possible people sometimes like to write clever code that has more complicated things in these three parts. If you see that and you're like, what does this do? You can write it out as a while loop, and it usually, at least to me, becomes more clear what the code is doing. So, here we have some code that uses a for loop. So first of all, we'll create a variable called sum. Then we have a for loop, and we say for int I equals 0, I less than 5, plus plus I. So this is the initializer, the condition, and the increment. And then in the body of the loop, we're updating the value of this sum variable up here. So whatever it has in there at the moment, plus I. We can write this as sum equals sum plus I. There's another little bit of shorthand. We could write it as sum plus equals I. Either of the two are equivalent. Doesn't really matter which one we do. Pick and choose which one you like better. So I guess I might have given you a bit of a clue with the variable name, but what is this code doing? Well, first of all, let's not worry about what the whole code is doing. What is this for loop doing?
Adding numbers.
Well, so let's not worry about the body yet. What's this first line? This for int I equals 0, I less than 5, plus plus I. What is that doing? So it's incrementing something. So what this is saying is do something 5 times. That is what this is saying. And as you get more experience, as you write more code, as you read more code, you will begin to just recognize this as do something 5 times.
Just in case anyone's confused why it's 5 times. 0, 1, 2, 3, 4.
So in the body of this loop, what we're doing is every time we go through, we are adding the current value of I to our sum variable, which starts out as 0. So first of all, we're going to do 0 plus 0, which is still 0. Then we're going to do 0 plus 1, which is 1. Then we're going to do 1 plus 2, which is 3. Then we're going to do 3 plus 4, which is 7. Then what are we going to do? Then it stops. I think I made a mistake. Well, I have made a mistake. Apologies, there's a typo on this. There we are, that's better. Doesn't have extraneous characters. Okay, so let's rewrite this as a while loop. Okay, every for loop can be rewritten as a while loop, so just as a bit of practice, let's do it. So, how do we go about rewriting this as a while loop? Int I equals 0. So first of all, we have this first component, the initializer, sits by itself. Very good. What comes next? While I is less than 5. You're going to have to talk me through the whole thing now. Sorry, you volunteered. Sorry, and what comes next? Oh, I haven't quite finished the while loop yet. I have to increment the I, yeah.
Anybody want to have a go at shortening that down?
No. So, these two bits of code are equivalent. They do the same thing. Right? Every for loop can be rewritten as a while loop. The only purpose of the for keyword is that it's a bit shorter than writing all of this. That's the only reason it exists. Syntactic sugar, as I said. Right? And the way we can translate it is, first of all, we write the initializer, then it's while, condition, and then we chuck the increment just as the last statement before the closing brace. And that's why, again, why I was trying to really drill in this idea that if you understand what was going on in that while statement example that I put on like hours ago now, that's the key. If you understand that, you understand all the other loops you are going to see in C++ ever. In fact, I said at the beginning there are two looping keywords, while and for. Well, for doesn't even really count.
Should we do one extra thing? Declare variable sum.
Well, that's implied. I didn't want to take up too much space on the board. While loops, do while loops, which are a bit weird. You don't see them very often, but they're pretty much the same as while loops. They just run the body at least once before testing. And we have for loops, which are shorthand for writing while loops. There is one other way of doing it that again is shorthand for writing a while loop, or rather shorthand for writing a for loop, which is shorthand for writing a while loop. And, oh, you get all of this in one go. No, never mind bullet by bullet, but we'll talk about it anyway. So there's a new addition that was added to C++ 11, something that is not in C, but many languages have some equivalent of it. And this is a convenient way of doing something for each element in a collection. And we already saw an example of this when we were looking at the vector code from last week. We have something that's called a range for loop. And this is useful with when we have types that meet the requirements of the C++ range protocol, if you like. It's not the technical term for it. But something that is a collection of items we can use with this and meets the requirement of the range protocol, we can use with these range for loops. It's just, again, a convenient way, a convenience thing, a bit more syntactic sugar. And all the standard library collection types implement this range protocol, right? So vector, string, map, set, unordered map, blah, blah, all of them, right? They all meet the, you can use them all with a range for loop. And we already saw a way of doing this earlier in the lesson. The way we write this is, again, we use the for keyword, but the thing that appears in the brackets is slightly different this time. Because instead of 3 elements that are separated by semicolons, we have 2 elements that are separated by a colon this time. This time this is not a typo, this is not cut off, this is a colon, not a semicolon. So when we have a range of elements, like a vector of ints, say, then we go, okay, for each int I in our vector, do stuff. It's a way of iterating over every element of a container. That's why this exists. Note the use of a colon, not a semicolon in there. That's how we tell the difference between the old school 3-element for loop, this thing that's on the board up here, and the newfangled range for loop, is we use a colon instead of a semicolon. And what this does, well, as I mentioned, it's just shorthand, it's just a convenience thing. You don't have to use it, although I'd recommend it because it's usually easier to read. But the code is
So it's like double slash, yeah?
double slash. What?
We have this, when you had this stuff. So it's really, there's a slash in the start. So it's
Oh yes, sorry. This is one way of writing a comment. There are 2 ways of writing comments. So a comment is just a bit of text that's for the information of the programmer. The compiler ignores it. There are 2 ways of writing comments in C++, as with many other languages. One way is to do this /* some text followed by */. In that case, the text can cover multiple lines. The other way of doing it is to do 2 slashes, and then the rest of the line is a comment, and your code begins on the next line. So,
And here is the closed, yeah? Then
yeah. So if I had some code there, then that would be code, not comment.
so that's it.
Well, either or. But when we use this, what we call the range for loop, this is translated roughly, more or less, it's a little bit more complicated really, but it's translated more or less into something that looks like this. So again, this is the do something a set number of times. So we initialize a counter to 0 while the counter is less than range.size. If we imagine we're going through a vector, it has this .size command, as we saw, that can tell you how many elements are in it. So while the counter is less than the size of the range, we increment we do the stuff, and then we increment the counter, and then we test again. And it's as if it has inserted in the top of your loop a variable declaration that is type name equals element I of our range. Yeah.
On the top we've got a colon
Yep.
that separates the 2.
Yep.
Is it not on the bottom? Or is it?
No. So there are 2. The keyword for is used for 2 distinct things. This is the bottom one is what we call the traditional for loop, and that has these three parts: the initializer, the condition, and the increment, and they're separated by semicolons.
Yeah, the first version that we did,
Yeah, and that's what's on the board. That's what we were talking about a few minutes ago. There is this newfangled thing called a range for loop. Some languages call it for each. In C++, because C++ had already been around for about 20 years, by the time they'd introduced this, they thought if we put a new keyword in there, it's going to break a lot of people's code. So what we're going to do instead is we're going to repurpose the word for, and we're going to give it a slightly different syntax that is irritatingly quite similar when you first look at it to this, because the difference is that this one has 2 components rather than 3, and we have a colon rather than a semicolon. And this first form is basically shorthand for doing roughly this second one. And this is convenient when you're using something like a vector or a similar container class, and you want to, which is very, very common, you want to perform some action for every element, for each element in the container. Then this syntax, this ranged for loop as we call it, this is really convenient. As you can see, it's a bit less code than doing this, which is what you would have to do otherwise. Yeah, oh, sorry.
We do this for type element. How we keep the range? How can we?
Well, you imagine that up here you've got like standard vector of int range equals something, and then this just refers to some variable name that's defined up here.
So let's say I have in here std vector, std string name b, 4b, colon.
I'll show you an example on the next slide that might make it a bit more clear. Yeah, and you had a question about it.
Yeah. So for is it possible for the element to be a different type? Well, not for the vector. I don't know if it's true for every type of object, but for the vector, it has to be fixed type.
Yes.
So each element.
Yeah.
But there's another. So we declare again like a type element. Can it be different?
In principle, yes. Most of the time, actually, we'll talk about it next week, in fact. You can use the word, there's a word auto, which means like just use whatever the correct element type is, use that. But in principle, you know, in theory, you could have a range of floats and say double each element, and each float would be converted into a double for the purposes of your loop. You know, again, unless you're doing something really specialized, like 99% of the time, you're just going to want to use whatever the correct type is. So it turns out the auto keyword is really handy, and we'll talk about how that works next week, or next session.
This language evolved like a Java, very open.
All right, so let's just have like a 30-second diversion and tell you the history of C++. So C programming languages started off in, I think it was about 1971, 72. So it's getting on for 50 years old. 1979, young Danish graduate student, my name is Bjarne Strustrup. 1979, started working on a set of extensions to the C language to support initially object-oriented programming, which was just coming into fashion at the time. And he called this C with classes. And then C with classes became quite popular. I think it was about 1983, they realized that actually we'd added a lot more beyond just classes. So they changed the name to C++. This is kind of a pun on the like I++, like it's an increment over C. So they decided to rename the language C++. And then the way things were done with languages at those times, especially if you wanted to get a contract with the US government, which was very, very important, you needed to form like an international standard, right? So there's like a committee under the auspices of the ISO, the International Standards Organization, that defines what C++ is. And it's literally like a 1,200-page document that details exactly the rules of the language and the rules of the standard library. And this was formed, I think, in about 1990. And they worked for a while. They worked for a while. And in 1998, they published the first version of this standard document, this 1,200 pages of like really dense text. Yeah, yeah. So they published this in 1998. That version of the standard we now refer to as C++ 98. And then they did, I don't know what they did, but not very much for 13 years. And the next version that we got was an absolutely major update that completely transformed the language, And we call that version C++ 11, right? C++ 11 added tons and tons of changes. One of the things, for example, it introduced was this range for loop, for example. Many, many other things besides. Since then, they decided that that 13-year gap was far too long, and they don't want to do that again. So what they've decided to do now, or what they decided to do after C++ 11, was they're going to release a new version of the standard every 3 years. A new version of this 1,000 or something page document. So since then, we've had C++ 14, C++ 17, and just a couple of weeks ago, they finalized C++ 20. So we get a new update every 3 years. So there will be 23, 26, 29, 32. Well, that's the plan anyway. Who knows what's going to happen in the future, but that's the plan.
So if I learn, for example, one function, how to make one program, and after update, it can be a problem?
No. So the idea of these frequent updates is that they are all backwards compatible. Backwards compatibility is is of major importance in C++. They really don't want to break stuff, right? Because one of the reasons it's been so successful is, well, initially you could just take your old C code and run it, use it as C++. So it's like backwards compatible to C, and then now we've got, like I just said, C++ is 40 years old, and most C++ code still compiles today. So if, like, say today you've got a textbook on C++ 14, that doesn't mean that it's out of date when you start using C++ 20. It just means that 20 has some new stuff that you can start to learn. Perhaps it has nicer ways of doing things, more convenient ways of doing things. Like this is more convenient than writing the longhand for loop. We have this shorter way of doing it. It brings some fixes, sometimes new ways of doing things, but still retains that backwards compatibility. So no, you don't have to worry that all your knowledge is out of date every 3 years. That's not the way it works. That was a lot more than 30-second diversion on the history of C++, but there you go. All right.
Just
Whoops.
more the topic of diversion.
Yes.
Is C++ dying a little bit?
People keep predicting the death of C++ and have done for like the last 25 years, right? At least. Like Java was conceived with the entire intention of killing C++, and it has failed to do so. Is C++ dying? I don't think it is, but I make a living writing C++, so I hope it's not. But no, C++ remains one of the most popular languages in the world. Right? It's like one of the top 5 in use in the world. Right? And as I was saying, for really big programs that need to run really fast, there still is nothing better than C++. Right? That's why every PlayStation game you've ever played is written in C++. Things like that, yeah. If you're running Chrome on your laptop there, that's millions and millions of lines of C++. The number of it's hard to measure, but by all the estimates, the number of C++ programmers in the world continues to grow. I think and again, it's hard to get like absolute numbers, that it is growing more slowly than the total number of programmers across all languages. You know, so many people are getting into Python and JavaScript and stuff because they are like an easier stepping stone in a way. So perhaps C++'s market share is going down. I don't know. That's a hypothesis. But is the language dying? I really don't think it is. I attend C++ conferences, go and speak at them occasionally, and there's been, the last 5 years or so, has been an absolute explosion in these, and there are, like, every single year there are more conferences, there are more people going to the conferences. This thing about standardization I was talking about for the ISO, 5 years ago, average attendance was about 50 people. This last one that they had a couple of weeks ago, 250 people turned up. So yeah, you hear it sometimes as C++ dying. As somebody said, well, if C++ is dying, it's going to be a crowded funeral, right? It's going to be around for a while, quite a while yet.
But why people choosing the Java over the C++? Is it more stable? I hear that this code is a mess.
The long and the short of it is, it's easier.
It's easier.
It's easier. That's pretty much what it comes down to. C++ has been around for really getting off track. But never mind, who cares? You're a small group. Should we just forget about all this loop stuff and have a chat? Yeah, I'm going to sit down. Let's tell a story. Like C++, like Java is like a smaller language than C++. It can't do all the things that C++ can do, or it has fewer tools available, right? Like in Java, everything looks like an object. Everything looks, and they say when all you've got is a hammer, everything looks like a nail, and that's what Java is. And if you are kind of within the things Java was intended to deal with, then it's again, that's grown a lot since 1996 when it was first conceived. But pretty much it's a smaller language than C++. If you want to be an expert in all of it, there is less to learn in Java. It has like a garbage collector. It has various things that make it has fewer sharp edges. Right? It is harder to go wrong in a language like Java or like Python. That stuff doesn't come for free. And that's why C++ is pretty much unmatched in terms of performance. That is how fast your program how fast your program runs, uses fewer resources than pretty much any other programming language, right? Because you can do like absolutely kind of bare metal programming if you need that. And then in C++, we've got convenience things like standard vector, which is when your compiler optimizes it, is just as efficient as if you had used like low-level C code, but takes care of a lot of stuff for you automatically. I've forgotten what the question was. I've just been talking. Why do people use Java? Because it's easier. Yeah, if you stay within that, the things that they're designed to solve.
Java is, I feel that it's more slow than C++.
It's Java slower. I mean, on the whole, yes. Right? There are things. So Java runs on a virtual machine, and there are things the virtual machine can optimize incredibly well. And if you are lucky and only stay within that, Java can theoretically run as fast as C++ sometimes. Theoretically.
If you're really interested in stuff, there is a version of the Ruby programming language that was written to run on the Java virtual machine. And they talk specifically about writing Java code that is horrible to read, but happens to be really nice for the JVM to optimize. So you pay the cost of writing less readable code, but faster implementation of Ruby. As Tristan said, the bottom line is something like Java, it's going to use more memory. Most likely, it's going to have less efficiency. It's going to use more of your CPU cycles. But the upside is that you can hire lots and lots of Java programmers who aren't going to create a huge mess and destroy your business. If you hire a bunch of C++ programmers, you need to be really sure they know what they're doing, or you could end up with a lot of very, very angry customers.
All right.
One thing to add on the point of Java memory usage is like I often see how hungry C-line is.
C-line is written in Java.
And that's like where two modes meet.
Can we?
Practically, yeah, I agree that despite like you say that C++ is faster, in most of the cases, yes it is, but from the point of development speed, which is often more important, like it's much faster to develop a prototype and then a complete enterprise solution in Java rather than in C++. And sometimes it's like tons faster. As like, for example, 2 weeks versus half a year for production quality code. And therefore, like it's a trade-off. What do you want, like working application earlier or the fast application itself?
That's why we have so many apps with bugs.
Should we drag this back to talking about range for loops?
Yes, good idea.
Yeah. Right. All right. So, look at that. It's this stupid. I don't know why it does this, but anyway, whenever we have a range for loop, we can, if we want to, in our heads, translate it into a loop that looks like this. A for loop. The traditional for loop is the second form. So I'm going to pop it on the screen again. Whenever we have a range for loop, that's the one with the colon that looks like this, we can in our heads translate it into a for loop that looks like that, a traditional 3-element for loop or 3-part for loop. And of course, we can translate this back into a while loop. So really, there is only one fundamental construct in C++ for doing loops. And that's while. And if you understand while, you understand loops. We have a bit of like convenience, a bit of shorthand that is this 3-part for loop with the semicolons. And then we've got a bit more shorthand on top of that to make things even shorter, which is this range for loop. And this is useful when you're working with containers and you want to do something for each element in that container. That's the purpose of this. But we can always go from a range for loop to a longhand for loop, and from a for loop back to a while loop. Always. While is really the only thing we have. We just have some decoration for it. Shorthand to make it make you have to type less, basically. Everything is a while loop in the end. All right, we've been nattering for ages. We should have got onto this quite some time ago. I thought we were going to have extra time tonight, but we might not actually get to the end. But we'll see. We'll see what happened. I wanted you to have a little exercise of just practicing translate. So starting off with a range for loop, which is what you saw in the very first example, like 2 hours ago, or an hour and a half ago, of using a range for loop, and then translate that range for loop into a traditional for loop, and then translate that into a while loop. So do this process that we've been doing of working backwards and proving to yourself really that in the end everything is a while loop, just with varying levels of disguise. If you want to have a go at that. A couple of you are new, right? Yeah. So please go ahead and have a go at that if you like, and I'm just going to come along and talk to you guys.